Today, let us go over some necessary fundamentals to understand how to use Parasoft C, C++ test in analyzing safety critical C, C++ projects. I will use this small example here, and I will be using a cross compiler tool chain which will execute into the target box, which is a Raspberry Pi in ARM64 platform. Right now, I adjusted the make file by changing the G++ and GCC to the cross compiler equivalent. So first, I should make sure that my project builds. So I'll first type make, and we build successfully the binary, which is of ARM64 format. And of course, I cannot execute this binary here. So the project builds. It's time to start the process of analyzing it using Parasoft C++ test IDE. We need to generate a PDF file. A PDF file is a text file, and we need this CPP test trace utility from Parasoft in order to do that. The way CPP test trace works is that if you build your project using make, or whatever build script you have, could be Python or shell script, whatever it is, not just make, you just prefix that command with CPP test trace. It will form a process tree hierarchy with CPP test trace as the parent, make as the child, and subsequent compiler commands invoked by make, such as GCC, G++, or cross compiler, ARM64 compilers. All of this will be visible by CPP test trace via a technique used in CPP test trace, this LD preload technique, intercepting POSIX API calls such as fopen, xticve, and that is how CPP test trace is able to be aware of whatever make is doing, monitors recognize compiler patterns such as GCC, and then captures what C or C++ files are compiled and generates a PDF. So the CPP test trace can generate an inventory of who are the participating C and C++ source codes for the project. By default, CPP test trace recognize a lot of common compiler executable names such as GCC, Clang, and a lot of ARMs, but sometimes because these triples here, the compiler triples, are in many combinations, it will fail to recognize a pattern. In such cases, we need to help CPP test trace by telling what is the regular expression of that pattern where it needs to capture, and that regular expression is this one. A symptom of CPP test trace not catching the correct compiler name is failure to generate a BDF, such as if I type CPP distress make, it will succeed, but the BDF will not be generated. See? So in this case, we need to invoke it with additional help like this. So we are telling CPP distrace in the process tree hierarchy that will result from this invocation. We are telling CPP distrace to watch out for compiler invocations of this pattern. G++, GCC, and LD with this prefix. And then create a BDF from that. The BDF has been generated. You should review every generated BDF to double check that everything is there. In situations where a file is not there, such as decide the CPP could be missing, the reason is there is already an decided.o stale file from a previous build. This is one of the reasons that some files are missing, because it was not properly cleaned up when you generate the BDF. Now that the BDF is generated, it is time to load this BDF from the IDE. And since Parasoft uses the Eclipse technology, as Parasoft is only a plugin of the Eclipse IDE, Eclipse prefers to have a workspace. So we give Eclipse what Eclipse needs. A workspace, an empty workspace will be created. And then we will create a project and load the BDF file that we generated a while ago. This one. Cross compilers comes in many forms and many names, so they cannot be expected to be auto-detected. The permutation is a lot. So this is the time where you need to be familiar with which compiler family matches your toolchain. For this particular one, I know that it matches this compiler definition here. This one. Yes, the evidence of a close match or a match is that the compiler name is close to what you're using. So here it auto sets the C++ linker to these names. If we recall, our compiler name is this one. These are the host target triples, okay? So it comes close. So this is one hint, but we still need to correct what is populated here, as this is the compiler that it will invoke during cross compilation. So I will fix this. Now to the question of how to really identify the family, compiler family, exactly to a toolchain cannot be answered directly. This requires deep knowledge of compiler intrinsics, and you have to go to the vendor to get this information. The compiler families in Parasoft are specified as C++, C++ front ends in EDG, the Edison Design Group. They are the masters of these C and C++ front ends. Click Finished. To review what we just set, which is the compiler family, you can right click here, go to properties and select Parasoft C++ build settings. So this is one of those places where you can set additional options such as preprocessor macro, linker options, and compiler options. A healthy check is to do a static analysis first. I can just select one file like account.cpp to statically analyze. Now, a failure in compiler family match will immediately throw an error during static analysis. So we are just analyzing account.cpp here as I'm selecting the single file. And static analysis has completed, no violations found, or I can select the whole node here and all files will be statically analyzed. Now, a successful static analysis is a good hint that we are on our way, that our compiler family is indeed correct, but it's at least 80% or 75% correct. Next, we auto-generate test cases. Generate unit test. And unit test cases have been auto-generated. And then lastly, we run the unit test. However, all of what we did did not introduce yet who is the target. To recall, our target is from a remote address. This IP address, or you can use the alias, which is box. Our configuration did not yet introduce this one. So our setup here in the IDE has no idea where to execute it. To introduce the target, you need to adjust a configuration. Go to test configurations, and there are templates here such as run unit test if you are just using native, that is compile locally and run locally. For cross compilation, the templates are under embedded systems. There are a lot based on the toolchain. Here, run test for targets with SSH service is a good starting place. Every template here can be selected and adjusted and tuned. So we have to start at the closest template as possible so that any adjustments that we made are just minimal. After all, this is just a text file. So I will duplicate this and then it will appear under user defined. To avoid confusion, I will put my here to rename this die, and then I will switch to the execution tab. So it does not know where the target is. So we will tell it. So I will edit this one and then tell the IP address of the target. And then of course the directory is, the target is DX. I know this. So you should know this also for your case. And the username is DX. Now I set up my target passwordless SSH using SSH public private key. If you do not set up, it will pop a dialog when running unit test. And then now that we are here, let me explain something. By default, this will only give you the line coverage, but if you want more, select more here, decision and MCDC. You have to be careful in the settings here. If the target has low memory, then adding more coverage will bloat the generated binary and the errors will not be obvious, like coverage generated in some places and not in other places. So an excess in memory that the target can handle will produce a difficult to trace error. So make sure that you know the RAM or the memory of your target, including the need for contiguous memory. Like some microcontrollers have segmented memory allocations, and you need to make some adjustments there in the linker script. Okay. Okay. And then to demystify what's been happening here, since a lot of GUI is hiding the truth, I will show you the XML configuration here. This is an XML. I suggest that you copy this XML into a text file and then stare it for a long time. So this XML flows from top to bottom. Okay, so that everything from top starts first, followed by the bottom. So that is the implied sequence. And from that information, you can see that the custom step that occurs here, which is first the SSH, then the chmod here, the ECP, all follows the top to down ordering. So at the top here, what's happening is the cross compilation of your firmware. It will be located somewhere in the workspace of the project, and then combined with a custom step. The custom step is the extra provision, because embedded arrangements are not standardized. Alright, some are using serial communication, some are using other weird communication. No GUI can represent the entire scenario. The only representation that can claim the utmost flexibility of this varied laboratory condition is an XML such as this one. So here we use SCP. In other cases, I use OpenOCD. Is the target is uses serial communication. So you can imagine now that this is the part where a lot of customization happens. Alright, so I will close this, and now that I explained this, I introduced. Alright, this one did not save. Okay, let me do it again. It reset. Okay, so let me do that again. DX, and I will save this. Apply. Okay, it is persisted now, so I will close. The target is now properly introduced. The GUI knows where the cross-compiled firmware is destinations going to. It knows how to run it there, and it knows how to copy the results back from the XML. Let us now execute the project, a cross-compiled firmware to the target using user-defined embedded systems and my run test for targets with SSH. So there's no magic now. From that configuration I showed a while ago, we introduced the IP address of the target. I showed you the SSH, the SCP, the chmod. What happened here is just automation. I'll click this. Go to console tab to see if there are error logs. In a Linux machine, which is pure Linux based, okay, I will not encounter this problem because I'm using MinGW. So my IDE detected a Win32, but the target actually is Linux, so we need to do some adjustments, and to fix that is to remove some headers here. The symbols, remove these stubs. And then rerun the rule set, the custom configuration. Always check for the console tab to see the process in action. So some Parasoft runtime source codes participates and gets cross-compiled, especially the transport, and it will join your firmware. And there it is. Coverage here. Okay, let me generate a report. LC for line coverage, DC for decision, MCDC for modified condition decision coverage. Interesting. Let me remove these results. I can also selectively just run this one. Let me do that. Or odd num, just odd num. Right click. There's also a history here. Let's see what happens. Right, and let's go to the add num here. So in this case, we are just running one test case for the add num function. So it's a very granular way you can select a lot of test cases inside. Okay, all of this you can select and run it. Go to history. So the rest of the test cases did not execute. In this case, only the selected ones are executed. So the whole process of cross compilation and copying to the target is happening here. So here we have code coverage completed for odd num. We can go to the target, for example, and we can see the cross-compiled firmware here. This is the one. This is a cross-compiled. So MD5 sum. Okay. Let me go to the workspace. And locate this file. And here it is. So let us compute the checksum of this. And we can see it's a bit for bit match. So cross-compiled firmware is in your workspace in this location. Copied to the target. We just run it on the target manually. And then log files have been auto-generated. And this is exactly what the IDE here setting is doing. If you review the XML configuration here, the copying of the log file here, see, through SSH, it's been deleted after execution. It's copied to the workspace location, and it becomes the basis of code coverage. That is all.